Please welcome Senior Developer Programs Engineer, Eric Bidelman.
Hello, everyone. Thank you. This is my first time in Japan, so it's very exciting. Welcome to Bleeding Edge HTML5. Now, when we say bleeding edge, this stuff has just come to HTML5. It's just come to Chrome and the modern browsers. There's a lot of really cool stuff now that I'm going to show you in this presentation that you probably haven't seen before. This is a space that changes very, very quickly. So my name, just to introduce myself, my name is Eric Bidelman, and I essentially travel the world, talking to developers about HTML5 and modern browsers and how to build, modern web applications. So if you're interested in following me, I have a Google Plus profile under my name, and then also Twitter if you want to tweet at me. And feel free during the session. We have the GDD 11 hashtags, and Chrome 1 is the session hashtag. And so the point I kind of want to make throughout this entire presentation is that Chrome is really best friends with HTML5. So Chrome gets very excited about HTML5. These guys are best friends. So Chrome really, and there's no JavaScript on this page. This is all just CSS3 doing all this with hover states. And that's really the awesome promise that HTML5 gives us, is all this power under the hood for very little. I want to show you a really fantastic infographic. How many people have seen this infographic? Cool. I unfortunately wasn't at the keynote. I don't know if they showed it at the keynote. But this is a wonderful representation of sort of where we've come with HTML5 and the modern browsers. Now, if we go all the way back to the 1990s, this is the first web browser. This is what we had to deal with. But if we fast forward to now, to when Chrome came out around 3 years ago, these dots right here, the closer these dots are together, the more APIs that are coming out for developers, the more developers are winning and have things to play with. So every 6 weeks, Chrome has a new version that comes out, which means all of these new APIs are coming out at a quicker rate than they were before. And it's not just Chrome. It's not just Chrome at all. It's Firefox has hopped on board with the same release cycle. IE Internet Explorer is on the same quicker release cycle than they used to be. So everybody is really innovating in the space of HTML5, which is super exciting as a web developer. So before we jump into this stuff, I just want to give you a big warning. Again, everything I'm going to show you is bleeding edge. It's brand new. And there's a lot of stuff here that could crash my browser. I'm running the nightly build of Chrome. We'll see what happens, but it's going to be an exciting ride. So I want to focus on sort of two different sections. The first section is building intelligent web applications. What are some of the new APIs that we can use in HTML5 to build smarter applications? So the first one is around smarter animations. If you've ever tried to animate something on the screen, you've probably done something like this, right? There's a window set timeout, and we want to animate something like a box or a div on the page. We want to animate that and change maybe the left property using CSS. And we'll try to do that at 60 frames a second. And so that's typically how jQuery or one of these animation libraries does an animation. But what we actually have now is a better way to do animations in the browser. And that is Requestanimationframe. And you can see that we have actually very good support for Requestanimationframe. So Internet Explorer, WebKit browsers, and Firefox now support this new way to do animations. And just by this code snippet, you can see it's very, very similar to what we had before with setTimeout. The big difference is that we're not actually passing in a value here. We're not passing in 60 frames a second. We're just saying, browser, go ahead and draw this animation as quickly as you can, but we're not setting up a contract with the browser ourselves. We're just letting it do all the hard work for us. The other point I want to mention is that it's the exact same semantically as the set timeout. So we'll just set up a callback and just repeatedly call that back as fast as we can. Now, what the browser can do with Requestanimationframe is a number of optimizations. So the first thing it can do is cap our animation rate at 60 Hertz. So this projector, my laptop, can only render things on the screen at around 60 Hertz. So let's not try to draw things faster than the monitor can actually produce. That's going to waste CPU. That's going to waste battery power. Your users aren't going to be too happy with you. So that's one optimization. The other optimization is that if the content itself isn't being displayed to the user, if they can't actually see your animation, maybe it's not on the current tab, maybe it's display none with CSS, there's no point to actually draw this stuff. So the browser can make a smart choice and not draw what's on the screen. So I think this is best served with a demo. And I have two different demos set up. So the first one is the old way to do animations. And I'll just click this. So what we're doing is we have that set timeout. We're calling this draw callback every 10 milliseconds. But you can see at the bottom here, the browser's actually already broken this contract that we set up. So it's drawing this, or calling this method, this draw method, at 11 or 12 milliseconds. So it's already lying to us. So that's no good. And you can also see that it's drawing faster than these monitors can keep up with. So we're wasting, again, CPU and battery of the laptop if I wasn't plugged in. So let's switch to the new hotness, which is the Requestanimationframe. And you can see down here, not much has changed, and that is perfect. Semantically, it's exactly the same as set timeout. But you'll notice I'm not passing in 10 milliseconds. The browser's just going to draw this as fast as it wants to draw this. So we're drawing around 16 milliseconds, 17 milliseconds. That's OK. It's as fast as we can draw. But you can see what Chrome is doing is capping the animation at around 60 Hertz. It's very fast, but we're not drawing faster than the monitor can keep up with. So this is really great. The other optimization I mentioned is whether or not the content is actually being displayed. So I've just zoomed in on my tab here, and I'm changing the title of the tab as this callback is being called. Now watch what happens when I open a new tab. So immediately, the browser's smart enough to stop calling my callback because it knows the tab isn't currently visible. So that's great. We're not wasting CPU. And of course, if I close that tab, that callback will start being called again, and that animation picks right back up where it was at. So that is Requestanimationframe. Smarter animations now in HTML5. Another new API is the Page Visibility API. And a lot of these APIs are very similar. It gives you more insight into your application, what exactly is going on. And the Page Visibility API is very, very simple. So we have a new event that we can listen to, the visibility change event. And within that, we can detect whether or not our document is hidden, whether it's visible to the user, or whether it's, and what state it's in. So there's a couple different visibility states that I'll discuss in just a second. But let me show you a demo of this. So this is an HTML5 video that's playing very happily in my browser. I'm doing something very similar as the last demo. I'm updating the title of the document as this video is playing. And so when I open a new tab, this application, this HTML5 video, can detect whether the tab is visible or not, and we can call video.stop. And no longer is that video playing in the background. I don't know about you guys, but sometimes I have 10 YouTube videos open. I have no idea what's playing. I have no idea what's creating audio. So this Page Visibility API is here to solve that problem. And of course, when I close the tab, the video starts right back up just using a little bit of JavaScript and the Page Visibility API. It's a cute video. So again, very little code, right? But a lot of power there. I mean, you can do things like stop animations or stop making XHR requests to update your mail. If the user isn't viewing your tab or your application, there's no reason to do this extra work. Something that goes very closely with the page visibility API is being able to pre-render content. So the use case here is something like a Google search. The user is likely going to click on the first search result because it's probably the best result. And so why not tell the browser or give it some kind of hint that we think the user is probably going to engage with that content. And so let's pre-render that. Let's pull down all the JavaScript and the CSS and the HTML and pre-render that inside of a background tab. And so what we can do is give the browser a hint with this rel attribute, this pre-render attribute. So let me pop out a full screen here to show this demo. I'm going to bring up Chrome's Task Manager to show you exactly what's happening in the background. So this is a demo of the pre-rendering. Some engineers on the Chrome team put this together. I want to show you what happens when I visit a news site like CNN. So there's a lot of big images. We're still loading the page. It's still downloading JavaScript. OK, so just finished. So that's maybe 5 seconds, 6 seconds, waiting for the site to load. But instead, what I can do is I can choose to pre-render that site. So this is just using that rel equals pre-render. And check out what happens in Chrome's Task Manager. So Chrome has actually fired up a background tab. And you can see it's got some CPU, it's got some memory. So it's actually pulling down all the JavaScript and CSS. Now when I click this, the page instantaneously loads. And so that's great. That's instant browsing of the web, right? Using this pre-render attribute. And again, what happened there is that everything was rendered. The page was rendered in a background tab. And when the user clicked that link, it's just instant for them. So instant browsing. And so that's exactly where this attribute, this page visibility state attribute, comes into play. So this will give you a string value, hidden, visible, or pre-render. And so you can exactly tell what state your page is in when it's loading. And so for pre-rendering, document.visibility_state would be in the pre-render mode. Next thing we can do that's brand new, other browsers, maybe Firefox has had this for a long time, but it's just come to WebKit, is being able to detect when you're online or offline. Now this might not seem like a big deal, but it's certainly a lot better than it was before. You had to constantly do a polling, maybe using XHR or something like that, to know if you have an internet connection or not. And so the smart folks around the web community decided this wasn't good enough. So instead, what we have now is this navigator.online. So this is a Boolean value, true if the page, if the application is connected to some kind of internet connection, and false if the connection is flaky or disconnected for some reason. And then in our app, we can listen for two events. We can listen for the online event or the offline event. And so when we're online, we know we can sync data to the cloud, right? And then when we get the offline event, we can use, say, HTML5 offline technology, IndexedDB, Web SQL, to queue up data, store that offline, and then we can resync with the cloud when we get the online event. OK, so here's a demo of this. I am going to do something you should never do in a presentation, which is disconnect from the Wi-Fi. I'm actually plugged into the LAN, but I'm going to take out the LAN and watch what happens to this page. So immediately, this app detected that we're offline. So now I can start queuing up data or adjusting for that case. Now when I plug in again, we get the online event. All right, cool. We get the online event, and we immediately can start resyncing to the cloud. So 2 lines of code, a lot of power in those 2 lines of code. More visibility into building smarter applications. OK. So the last API, and the biggest one in this section about building smarter apps, is a new project called Web Intents. How many people have heard about Web Intents? a few, very few. Let me tell you a little story. So if you're an application developer and you're building an application, you might want to offer some services and you don't want to have to build those services out. So let's say you wanted to integrate with some social bookmarking services. You look up how many social bookmarking services there are, and you get a list of, 30 social bookmarking services that you have to integrate with. That is impossible to deal with, right? That's a huge, huge pain. And that's just social bookmarking. What if you wanted to integrate with photo sharing services or video sharing services, blogging services? This list goes on and on and on. That is a huge problem. We shouldn't have to do that. I have no idea, what services will be popular a year from now, or 6 months from now, even 3 months from now. So WebIntents is here to solve all of this. And by definition, WebIntents is a framework for client-side service discovery and inter-application communication. And so what does that actually mean? If this whole thing sounds a little bit familiar to you, it's exactly the same thing that Android has done. So as an Android developer, I can write an application and then sort of register it. If I'm a photo sharing service, for example, and the user wants to share a photo in Android, they can choose my application from a list of photo sharing services. And so this is exactly what WebIntents is doing for the web applications. It's bringing this ease of sharing across the web. And so the way this works is very straightforward, as most things are now in HTML5. It's really simplifying a lot of the desktop capabilities. As a service, I can register myself to provide some kind of activity. So in this example, I'll use the intent tag, and I'm going to register the application as a sharing intent. I'm going to share something with this application. And then I'm going to share image types. So if we're, say, a photo sharing service, this makes a lot of sense, right? So we'll just be able to handle all image types. And you can optionally specify what URL the user is going to open when they visit your application, or when this intent process starts. So one tag, the service registers itself. The second step is that your application, the one you're building, the one that you want to integrate with this photo sharing service, sets up this intent. So it starts an activity. And so what you'll do is create an intent. We're interested in a sharing intent, and we're interested in sharing images with this third-party service. We can optionally pass it data. So if I have a picture, say, in my app, I can pass this picture to this photo sharing service. And that's done through this intent.data attribute. And then to start this whole flow, we'll call navigator.startActivity. We'll pass it the intent, and then we can optionally also register a callback. So if that third-party photo sharing service has any data to pass back to us, this is how we get it. And then the last step, the third step, is when the user selects the application they want to use to share photos with, that application will fire up, and on the intent.data property, that's where this data is passed. So in this example, I was passing an image as a data URL. And so that's how the third-party service gets the data that you pass it. And so the user's in this third-party service, they're editing a photo or doing something, or selecting a photo, and then that third-party service passes the data back through this post-result method. So then what? And that's actually it. So WebIntents is super, super simple. And you've basically integrated with all services everywhere on the web, whether they be popular now or in 6 months, as long as they do this WebIntents flow. So let's see a demo of this. If none of that made any sense to you at all, most things are best served with a demo. I'm going to pop out of full screen mode. OK, so I mentioned the very first thing you need to do is visit some kind of third-party service. So this is, let's say this is a fantastic photo sharing service. It's not that exciting, but I want to show you what is going on this page. So up in the head tag, this page has registered 2 intents. So this web app, this third-party photo service, is going to handle pick operations, so we'll pick a photo from this service. It'll handle image types, and there's two different intents. So basically, this app has two different endpoints to handle picking of photos. So it'll open pic.html or google.html. So as a user, I'm using this third-party service. But then I'm back in your application, the one that you're building, that wants to integrate with the tab I just closed. So I'm in this application. I want to pick a photo to do something interesting in this application. So the first thing that happens is the user selects which application they want to use to handle this pick intent. So I'll pick cat image picker, because it's my fave. And so we're taken to pic.html. That's the endpoint that the app specified, the service specified. Which one should I pick? 1, 2, or 3? 2? I saw 2. We'll pick 2. 2 is very cute. So I'm in this third-party service. I'm going to select this image. And with a little JavaScript, that page is going to close itself. And using that post result, we're passed back the image data from that third-party service. So I've just integrated with that photo sharing service very, very easily. Let's see that one more time. So I'll go back to cat. Say this is Flickr. This is Picasa. We'll select this guy. He's very cute. And again, I'm passed back that data through that post result callback. And you can imagine this is not just for photos, right? This is for maybe you're selecting an online document in the cloud, or you saw blogging or URL shortening, for example. There's a lot of use cases that Web Intents handles. Okay, so now let's get to the really fun stuff. Now HTML5, of course, has a ton of capabilities regarding multimedia. But there's a lot of new stuff that has just come out or is coming out in the next couple of months. The first thing that I am particularly excited about is being able to access the camera and microphone. So without a plugin like Flash, this is built in now to the browser, or it very soon will be. Unfortunately, it's too new and I don't have a demo of it. But the way this is going to work is natively in the browser, we'll be able to stream camera data or get access to the microphone. And so we'll use the video tag, right, just the HTML5 video tag, and we can set up a record button and a stop button, just basic markup. And the new method here is navigator.getUserMedia. So this will allow us to get access to the video camera or the microphone. So we're interested in video, so I'll pass it video for that first parameter. And then what we get back is a stream, some kind of stream object. And we'll fill the video tag, the source tag, basically create a URL on the fly, pass it that stream object, and then everything that comes through the camera is going to be directed to that video tag. And so that's how you get access to one of these devices, these native devices. And for recording, you can do things like set up a media stream record, and you can call stop, attach these buttons, and then you basically can create a file. You can create a video file on the fly, calling recorder.getRecorded data. And then you could upload that file to your server. You could do video editing application. The possibilities here are very, very, very endless. But again, a lot of power, native access to some of these devices on the machine now. Second thing that is ready, and that I have a demo for, is being able to programmatically go into full screen. Now, why would you want to do this? Well, the first use case is games, right? If we have things like WebGL and Canvas games, HTML5 video, we want everything else to get out of the way. The content should take precedence. And so this API, as a lot of these are, you're seeing a common theme, is very simple. So any element now we can tell to go into full screen. So WebKit request full screen, and if we want to have keyboard events associated with that element, we can pass this parameter in. And so I can tell a video, I can tell a canvas tag, I can tell a div or any markup on the page, anything in the DOM to go full screen. So let's just quickly see a demo of that. I'm going to pop out of the browser's full screen and open this demo. Okay. So let's say this is a news site, right? There's or a magazine, an online magazine. It's got CSS multiple columns. It's got embedded multimedia and video. And what I've done is attach some keyboard listeners on this page. So if I press the F key, I can use this WebKit request full screen and programmatically go into full screen mode. If I press escape, I can go out of that mode. I want you to notice what's happening. So I've actually told this div here to go into full screen. This div has a title. It's got some text down here. It's got a button associated with it. But when I go into full screen, I actually have new CSS Pseudo Selectors that I can use to style that div. So the first thing you notice is that title that was at the top of the div is now gone. So I've hidden it in full screen mode. The video is the most important thing that I want to emphasize, and I can style it accordingly. So I've made the video go 100% width and 100% height. And you can also see that I've changed the text down here based on the fact that I'm in full screen mode. Now, the browser has had this for a while, right? The enter presentation mode, the kiosk mode. But this is really going to be great for things like games. And that's exactly what this HTML5 presentation has done. I'm just listening for the F key again, and I can make the presentation go in and out of full screen with that. So that's very exciting for things like multimedia and games, full screen. One of the most important things we're doing now with multimedia in HTML5 is real-time communication. So being able to communicate in real time with people. You saw that as one of the, the main talking points of this morning's keynote. And so the demand for real-time communication on the web under this multimedia umbrella is very, very big. So things like the Gmail chat with video and audio. Things like Google Hangouts, where you have 10 or more people chatting in real time with video and audio. Facebook has an integrated plugin for Skype, so you can do online video chatting as well. And there's also third-party APIs and services that you can use to integrate with real-time communication type setups. Now, all of these are fantastic, but all of these require a plugin. And so what, again, HTML5 is trying to do is remove the requirement of a plugin. This stuff should all be native inside of the browser now. And that's exactly what the WebRTC project is here for. So there's a lot of stuff on this diagram. Don't worry about it. This API has a ton of power under the hood. So this is something that the browser vendors, Firefox, Chrome, Safari, Opera, are implementing. So there's things like a video engine and a voice engine to do noise cancellation and video processing. But the part you get to play with as a web developer is up here. So there's a whole set of APIs, JavaScript APIs, coming down the pipeline that you can tie into very easily to do real-time video and do real-time audio with access to the camera and microphone, as you just saw. So unfortunately, this stuff is just as bleeding edge as the other sections, and I don't have a demo for it. But to get your mind thinking about what you could possibly build with this, we could build real social networks, right? Things like Google Hangouts, but do that natively with video and audio. You could do interactive commerce, so breaking sort of the paradigms of today. You could build online learning experiences with real-time communication. Online gaming is a natural fit. You could build a cool baby monitor if you wanted to, monitor your baby in real time using a web browser. Or you could build an interactive robot, as a web application and control it via WebSockets or something. So there's a lot of potential for WebRTC. I want to mention that this particular project is a community effort. It's not just Google Chrome. There's a whole site for it, so webrtc.org if you're interested in doing something with real-time communication. Mozilla and Opera are also working on this, along with Sony Ericsson, so there's a lot of input going into this. A lot of people are interested in online video and voice chat. Okay, this is my favorite section. So the whole multimedia story wouldn't be complete. We talked a little bit about video, but now we have to talk about audio. And you might be asking yourself, well, why are we going to talk about, HTML5 audio in a bleeding edge HTML5 talk? And I would say, yes, we already have the audio tag. It's been great, but it's only taken us so far. It can only do so much. What if you want to do things like low latency, glitch-free audio playback? What if you have a game and you want to schedule sounds at very, very precise times? The audio tag has had problems doing that, and you can't schedule sounds to play at exact times. What if you wanted to do things like real-time processing? Or if you want to analyze a sound. So the audio tag, you can play a sound, but you can't actually analyze it or do anything interesting with the sound as it's playing. What if you wanted to manipulate the sound as it was playing, actually change the bits and bytes of the sound as it's playing in real time? Can't do that with audio. And there's a whole set of specialized effects, things like spatial panning and filters and convolution that the audio tag is just not capable of. And so this is exactly where the web audio API comes into play. So of course, if we have an audio API, it should be able to play sounds and play them very well. So the way this API works is exactly sort of like the canvas element. So HTML5 canvas allows you to draw basically draw on the screen using JavaScript. This API allows you to draw sort of an overall sound system using a global audio context. So we'll set up this sound system, and then we basically just plug in different boxes, right? If you're familiar with audio, you kind of just connect the dots on some of this stuff. So if we're interested, for example, in just playing a sound, we have this source node. This is our audio file that we load up. And then we'll just pass that directly to the destination. We're just interested in playing it straight through. And so the way that works is that we'll create this WebKit audio context, so our global sort of sound system that we're creating. We'll load a sound file. We'll load it via a file input or an XHR request and get the sound, the MP3 file. We'll decode that audio data on the fly in JavaScript. We'll create that source node, calling create buffer source. That's this node here. We can specify whether it should loop or not. We fill the audio buffer data. We connect that source node to that destination node. And then calling source note on will just play that sound immediately at time 0. So I can do that. So that's cool. But the real power of this API is being able to play sound very, very quickly. Let's say you have a game, for instance, and you want, as soon as the user clicks, you want a gunshot to go off or, a boing to happen. So I can click this as many times as possible, and it's going to be just as clear and precise as it was before. So that's great. I can play sounds immediately. I can schedule them. So every 2 seconds, we can get really crazy. And so you can see it's not just about playing sounds, but say you have a music synthesizer or the drum machine you saw in the keynote today. That's exactly how that was achieved, by scheduling sounds at very precise times. So you see this global counter here. So it's basically a timestamp of this global audio context as this sound is playing in the background. So that's scheduled playback. But the real power of this API comes with being able to do something interesting with the audio as it's playing in the browser. And so for that, we'll do the exact same thing as before. But this time we have a new node. So we want to analyze the sound as it's playing. So we'll connect the source to this analyzer node and then pass that to the destination node. And once it's analyzed, we'll just play it. So it's a very similar process as before. We'll create the web audio context. And this time we'll create an analyzer node. So we'll call context.createAnalyzer. We'll load the audio file. We'll decode the audio data. We'll create that source node, fill the buffer. We'll connect the source to the analyzer to the destination, and then we'll call this magic render method. And so this render method is this guy right here. And we're actually reusing Requestanimationframe. So if you want to do something like an audio visualization, for example, that probably involves some kind of animation. So we'll use Requestanimationframe to do that. And we'll continue to call this Requestanimationframe callback and analyze the data. So we'll use a JavaScript typed array. So JavaScript now can actually deal with binary data. This is pretty exciting for WebGL and audio. We didn't have this data type, a year ago, but now we do. So we'll fill this typed array, this unsigned 8-bit array. We'll call it get byte frequency data, which will fill this array of values. And so this is the audio file as it's being played. We can basically render that array to a canvas tag or a WebGL context, or use CSS to manipulate it in some way. So let's see that in action. This is a new computer Google's working on. It's called GAL 9000. And GAL is just markup. So this is just a div with CSS rounded corners. There's drop shadows. We have gradients here, radial gradients. Actually, the only image on this page is this part right here where the little reflection happens. Everything else is markup. Everything else is CSS. So you're probably wondering what this has to do with audio.
Good afternoon, gentlemen and ladies. I am a GAL 9000 computer. I became operational at the Googleplex in Mountain View, California on the 4th of May, 2011. My instructor was Eric Schmidt, and he taught me how to sing a song. If you'd like to hear it, I can sing it for you. Just
okay.
What do you think?
So let me explain what's happening here. We're using the Web Audio API. So we recorded one of my colleagues' voice and basically recorded his voice, made an MP3 file from that.
But I can assure you
We're putting that into the Web Audio API and calling that get byte frequency data as it's being rendered in real time.
The Web Audio API.
And this section in the center here is just a canvas tag. So we're basically looping through the canvas tag and rendering each of the bins, which is all frequency data. So that's what's producing this effect that he's talking to you.
I feel much better.
The part in the center is just a CSS radial gradient. So as we're analyzing this sound in real time, I'm just changing the radius of that gradient as he's speaking. So that's what's making it sort of have that speaking effect.
Amazing. I've still got the greatest enthusiasm.
He can talk all day. So that's one visualization you can do, right? That's a little markup, that's a little CSS. You can do much, much more with the API, like effects and spatial panning. I'll show you a few more visualizations because I think that's some of the coolest stuff.
Dev Day Tokyo.
HTML5 logo.
Dev Day Tokyo.
So this is just a canvas tag that's rendering each of the bins of that frequency data. And we've overlaid it with the HTML5 logo as an SVG filter, and then applied CSS 3D transform on the whole thing. I mean, there's a lot going on here, right? This is analyzing sound in real time, 3D transforms using the GPU, rendering that data with an overlay. That's not just a canvas. I can bring in our Chrome logo and do a little bit of beat detection and apply reflection on the bottom there. You can see it's pretty nice using CSS. So this party is very exciting, but I think we're a little lonely. I'm going to bring in a friend, Android. So Android is just a bunch of markup, just like Hal was. His little ears are going, his little feet are twitching. He's just divs with rounded corners, CSS rounded corners. But watch what happens when he gets really excited.
Dev Day Tokyo. Dev Day Tokyo.
Okay, so there's a ton of stuff you can do there. I mean, that's just hitting the tip of the iceberg. Okay, so I have 4 minutes left. That was a ton of stuff. If you're interested in resources and staying up to date with some of the new stuff you saw today, one of the best places you can go to is chromestatus.com. Chromestatus.com is a website that my team, the developer relations team, puts together, and it's basically all of the APIs that are coming out in HTML5, in particular in Chrome, because oftentimes they come out first in Chrome. And so if you're interested in staying up to date, sort of issues with APIs when they come out, check out chromestatus.com. We post there all the time. Another great resource is HTML5 Rocks. How many people have heard of HTML5 Rocks? Cool. So this is a subdomain of HTML5 Rocks, which is our updates.html5 Rocks. And this is great. This is a way for us to make announcements. Of course, Halloween was just here, so somebody did the HTML5 logo. But as APIs are changing, as new stuff comes out, we will post code, we'll post announcements, we'll post demos, libraries and interesting stuff. So that is a great, great resource to keep up to date. Here's a couple more that I'll leave up for a little bit of time. The WebRTC project, there's Web Intents project, Web Audio, and the Get User Media, being able to access the camera data is there, and then the rest of the sites as well. So with that, I thank you. There again are my links, and I really appreciate your time in coming to this session. Thank you.
以上でセッションを終了させていただきます。